Every update and delete you run destroys data forever. What if your database never forgot anything? What if instead of overwriting data, you kept a record of every single change? And what if that one decision could save you from the worst production outage of your career? Let's take a look. Event sourcing is a pattern where you store every state change as an immutable event. Instead of saving the current state, you save the history of how you got there. Think of it like a bank ledger. You don't just store your balance, you store every deposit, withdrawal, and transfer. Your balance is calculated from that history. This pattern isn't academic theory. It powers some of the most critical systems in the world. Your bank's transaction ledger, Git version control, event-driven systems at LinkedIn, Netflix, and Uber. Even blockchain is just event sourcing with cryptographic proof. In a traditional system, you have a database with the current state. When you update a record, the old value is gone forever. In event sourcing, you have an event store. Every change is appended as a new event. The current state is rebuilt by replaying those events from the beginning. The event store is the heart of the system. It's an append-only log. Events go in, but they never get modified or deleted. Each event has a type, a timestamp, the data that changed, and the aggregate ID it belongs to. Think of it as a commit log for your business logic. Every event follows a simple structure: an event type like order placed or payment received, a timestamp for when it happened, the payload with the actual data, and metadata like who triggered it. Events are named in past tense because they represent facts that already happened. To get the current state, you replay all events for that entity from the beginning. Start with an empty state. Apply each event in order. The result is your current state. This is called state reconstitution. It's like rewinding and fast-forwarding a recording. Replaying events every time would be slow. That's where projections come in. A projection listens to events and builds a read-optimized view. You might have one projection for the dashboard, another for search, and another for analytics. Each read model is tailored to its specific use case. Event sourcing pairs naturally with CQRS, Command Query Responsibility Segregation. Commands write events to the event store. Queries read from projections. The write side and read side are completely separated. This lets you scale reads and writes independently. For aggregates with thousands of events, replaying from the beginning gets slow. Snapshots solve this. Periodically save the current state as a snapshot, then replay only the events after that snapshot. It's like a save point in a video game. The upsides are significant. Complete audit trail of every change. Time travel. You can rebuild state at any point in history. Debug production issues by replaying exactly what happened. Easy to add new read models retroactively. An event replay lets you fix bugs by reprocessing events with corrected logic. But there are real downsides. Eventual consistency between the event store and projections. Schema evolution is hard. What happens when your event format changes? Storage grows forever. The learning curve is steep for teams used to CRUD, and simple queries that were one SQL statement now require building dedicated projections. So when should you use event sourcing? Use it when audit trails are critical. Finance, healthcare, legal. When you need to understand not just what the state is, but how it got there. When you need multiple read models from the same data. Don't use it for simple CRUD apps or content management. The complexity isn't worth it unless you need the history. Event sourcing isn't a silver bullet, but for the right use case, it's the difference between flying blind and having a complete record of everything that happened. What's the most complex data pattern you've dealt with in production? Drop it in the comments. If you found this useful, subscribe for more architecture deep dives. Check out these videos next.